Hi everyone, today we have hydrodynamics and we'll be covering the topic efflux. So efflux is the response by the fluid when an orifice is created at a depth h with a speed v0, and we'll be calling this speed v0 as the velocity of the efflux or the efflux velocity. Also we'll be talking about the force acting on the container due to the exiting liquid. This proof is Bernoulli's theorem, wherein we have the pressure plus half rho v square plus rho g z as a constant. Applying the Bernoulli's theorem at position A and position B, so we'll have the Bernoulli's theorem hold true at A to B, right? So we know that the pressure at A is the atmospheric pressure, which is just P0, and the pressure at B will be P0 only. We have an orifice present here, hence the area is exposed to the atmosphere, so it is going to be P0 itself. Now for the pressure, we have P0 plus half rho, let us call this velocity at A be V1, plus rho g, Z1 is just the height, Z is just the height, right? That has to be equal to P0 plus half rho V2 squared plus rho g times 0. Also we can assume the velocity at point A to be negligible, right? It will almost be 0. So we have this term cancelling out with P0 and P0, this being 0 and this being 0. So the velocity V0 comes out to be root 2 g h, where h is the depth from the water level to the orifice. Now talking about the reaction force due to the exiting liquid, we have F as dp by dt d times mv over dt. In this scenario we have the velocity is some constant given value for any certain depth h, right? So the velocity is constant that will come out of the change, and the remaining change persists for the mass m. So we have dm over dt. Now this velocity is just the efflux velocity, so we'll be calling it as v0. It's v0 times, now the mass is just the density times the volume. Density in itself is a constant quantity, so we have rho coming out of the change, and the rest is just the change in volume, so the rate of change of volume, right? Add q as the discharge in a liquid, q as the area times the velocity, or it was also the rate of change in volume. Let us assume the area at this point to be small a. So we have v0 squared rho times area, which is hence the normal reaction or the force experienced by the container whenever a liquid of density rho is exiting from an orifice of a cross-sectional area small a with a velocity v0 liquid, right? So yeah, again that is it, and thank you for your time.